In this unit, we're going to be studying the present value of cash flows. We will look at how we obtain these using discount factors. We will also see how these discount factors are related to the accumulation factors that we met in a previous unit. In a previous unit, we looked at accumulations. For example, if we have €500 and invest that for 10 years, calculate the accumulated value of this investment at an effective rate of interest of 8% per annum. Recall that to accumulate over 10 years at 8% per annum effective, we multiplied by the accumulation factor 1.08 to the power of 10. This gives us €1,079 and 46 cents. However, we are often more interested in calculations the other way round. For example, suppose we now have a payment of €1,079 and 46 cents, which is due in 10 years' time, and we wish to calculate the present value of this payment at an effective rate of interest of 8% per annum. By present value, we mean what is the value of the $1,079.46 payment at the present time, i.e. time 0. Or to put it another way, how much should we invest at time 0 in order to meet this payment at time 10? This is a very common question, for example in life and pensions, where we may have liabilities to meet in the future, and we need to know how much to invest now, i.e. the premiums, in order to meet these payments. Okay, now to get the accumulation, we multiplied by the accumulation factor of 1.08 to the 10. So to go backwards, we could simply divide by 1.08 to the 10. However, suppose I was bitten by a divided sign when I was younger and wished to only use multiplication. In which case, to go backwards, we could simply multiply by 1 over 1.08 to the 10, or if you prefer, 1.08 to the minus 10. Now this is called our discount factor, i.e. what we multiply the €1,079 by to discount it, that is, to get the present value of this payment. Now in general, we denote this discount factor by Vn, i.e. what we multiply by to get the present value, hence V, of a payment due in n years' time. Well, as we saw in the example, our discount factor was simply 1 over our accumulation factor. So in general, Vn is 1 over An, our accumulation factor we met in a previous unit. Okay, let's introduce some notation for the effective discount factor. For an effective interest rate, where we have an accumulation factor of 1 plus I over 1 year, we define the discount factor for 1 year as V, which is obviously 1 over 1 plus I, or if you prefer, 1 plus I to the minus 1. So for n years, where we have an accumulation factor of 1 plus I to the n, so if we were discounting over n years, we would multiply by our discount factor, V to the n, or 1 over 1 plus I to the n, or if you prefer, 1 plus I to the minus n. Well, let's use this notation in some examples. Calculate the total present value of a payment of £300 in 5 years' time and a payment of £500 in 8 years' time at an effective rate of interest of 5%. Well, let's put this on a timeline first of all. So what we're asking is how much would we have to invest at time 0 in order to meet these payments of £300 at time 5 and £500 at time 8 if we're investing our money at time 0 at an effective rate of interest of 5% per annum. So we require the present value. So we have £300 in 5 years' time, so we need to discount that over 5 years. We multiply by our effective discount factor, V to the 5. We also have a payment of £500 in 8 years' time, so the present value of that will be 500 V to the 8. We're discounting that £500 over 8 years. Now at 5%, V to the 5, we could write 1 over 1.05 to the 5, or 1.05 to the minus 5. Similarly, V to the 8, we could write that as 1 over 1.05 to the 8, or 1.05 to the minus 8. Okay, putting that in our calculator, the first term will be £235.06. The second term will be £338.42, and so that gives us a total present value of £573.48. So if you invest this sum at time 0 at 5%, that means we'll have enough money to pay the £300 at time 5, and then once we've taken that out, the remaining amount which accumulates to time 8 will be exactly enough to pay the £500 there.
In summary, we have seen that we find present values using discount factors. These are simply the inverse of the accumulation factors that we met in a previous unit. For effective interest, we define V to be 1 over 1 plus I, i.e. the present value of a cash flow in 1 year's time. So to obtain the present value of a cash flow due in n years' time, we use V to the n, or 1 plus I to the minus n, as our discount factor.